Good morning, guys. Today we'll discuss regarding the Lagrange's interpolation formula. And today we have mainly two objectives. First objective is that we are trying to develop the algorithm for the Lagrange's interpolation formula. Second objective is that how we can develop a Matlab code for the Lagrange's interpolation formula. Okay, so mainly we have two purposes today. Now, before starting the coding, we should know the Lagrange's interpolations formula. What is this? Let me write here Lagrange's interpolation formula here. Lagrange's interpolation formula. Lagrange's interpolation formula we have. Now, if I talk about the Lagrange's interpolation formula, various type of question may arise here. Various type of question may arise here regarding the Lagrange's interpolation formula. Somebody may ask, what are the advantages of the Lagrange's interpolations formula? Because we have Newton divided difference interpolations formula. We have Newton forward backward interpolations formula. We have Stirling interpolations formula. So we have lots of interpolations formula. But the major advantage of the Lagrange's interpolations formula is that the nodes or arguments are not necessarily to be an equal space. For example, I have the value of x and I have the value of y. Okay, see, this x1, x2 up to xn plus 1, these are the nodes. The distance between two consecutive points is not necessarily equal in the case of Lagrange's interpolations formula. Okay, now you may ask the question that in the case of Newton divided difference interpolation formula also, we don't want equal space in the arguments. But answer is very simple. In the case of Newton divided difference interpolations formula, we need to develop a different code for the divided difference table. It means that Newton divided difference formula will talk about the construction of table, and then we have to talk about the interpolations formula. Means we have to develop two different type of code. One is for table, one is for interpolations. But in the case of Lagrange's interpolation formula, we don't require any type of table. Without table, we can do the construction here. Now, let us try to understand first what is the equation of Lagrange's interpolation formula. For example, I have the nodes x1, x2, x3 up to xn plus 1. It means I can get here degree of polynomial n. We can get here degree of polynomial n. Why? Because I have n plus 1 data set. The formula is like this here. F of x is equal to, suppose y1 L1 x. What is L1 is the function of x plus y2 L2 x, right? Plus y3 L3 x plus dot we can go up to y n plus 1 L n plus 1 x, because we are talking about the polynomial of degree n, so I need n plus 1 points. Let us put the equation number 1 here, right? Next, I can write this is in the form of summation form also. It means f of x can be written as summation, suppose I 1 to n plus 1. You may feel that why you are putting n plus 1 points. So we are talking about the polynomial of degree n. So we need to take the n plus 1 points, then only it is possible. This is yi and li. This is x. Suppose this is equation number 2. So this is the formula of the Lagrange interpolation formula in the expansion form. This is the formula for the Lagrange interpolation formula in the form of summation form. Now, what are the Li? If I don't know what are the Li, so I am not able to do it. So we need to first classify in the two cases. One case is for y, which is given in the table. The value of y will be given to you, but the value of Li has to be calculated. See, the value of y is coming from the given question. This is the points, values are given to you, and we need to calculate Li. So we can classify two parts. One is already given, and second part is we need to calculate. The formula is here. What is Li? Here, let us try to disclose what is L1x. Now, if I write the L1x, please be careful. It is very much important here. This is the x, means point of interpolations. X, see, x minus x2. Be careful here. I didn't start from x1. I start from x minus x2 into x minus x3 up to, it is going for x minus x n plus 1 points. If there is L1 in the numerator, there is no x1. So this algorithm we have to develop for the algorithm of Lagrange's interpolation formula. Be careful that if I want to find out the coefficient of y1, the coefficient of y1 is L1. In the numerator, it is x minus x2, x minus x3 up to x minus xn plus 1. So we didn't start from here x1. So we have to remember here. So in the denominator, look here. I started from here x1 minus x2. Be careful here. If I do write here x1 minus x1, it is going to be in infinite terms. See, x minus x2 into x1 minus x3, it is gone up to now x1 minus xn plus 1. What you observe there? If there is L1, then in the numerator, there is no x1. In the denominator, it is x minus x2, x1 minus x3 up to x1 minus xn plus 1. Why? Because if I do here x1 minus x1, it is become the terms defined undefined. What about the now coefficient of y2, which is called the L2x? Okay. Now L2x, how it is coming? Look here, it is very clear here. Now it is x minus x1 into x minus x3. Have you got my point? X minus x3 into x minus xn plus 1. What does that mean? If there is L2 in the numerator, there is no x2. It is start from x minus x1, x minus x3 up to x minus xn plus 1. What about the denominator? It is from x2 minus x1. Okay. Then x2 minus x3. There cannot be x2 minus x2. Otherwise, it is become undefined. Same thing, it is become x2 minus xn plus 1. Now, if I do extend this coefficient, suppose up to n plus 1, because I need the coefficient of yn plus 1. So coefficient of yn plus 1 is ln plus 1. Look here. It will be x minus x1, right? It will be x minus x2 dot dot. It is x minus xn. Because it is ln plus 1, so in the numerator there should not be xn plus 1. So it is up to only xn. This will be xn plus 1 n minus x1 into xn plus 1 minus this up to xn plus 1 minus xn. Have a listen here. For the coefficient of y1 also, there is no x1 in the denominator, numerator. In the case of denominator, there is no x1 minus x1. Okay. In the L2 also, same logic. In the Ln1 plus also, same logic has been applied now. Now, how to write this is in terms of our Li form. Li. What is I? I is moving from 1 to n plus 1. Now, these are all in the form of production form, right? So it is just the symbol of product, right? So I have here two part here. Here I is going from 1 to n plus 1. These are the I side. Coefficients of y's are the I side. So here I write this is minus, suppose xj, right? In a denominator, it is xi minus xj. Be careful here. What is the logic we have found here in the coefficient of y? If it is L2 in the numerator, there should not be x2. And denominator, there should not be x2 minus x2. It means that I can never be equal to z. I can never be. This I cannot be equal to z. If they are equal, it is become undefined. So this is the logic equation number 2 we have. L1, L2, L3, Ln plus 1 can be written in the form of general form. Li x is equal to, it is I 1 to n plus 1. But this I and j cannot be 0. Means it cannot be equal. If this and this are equal, then it is become 0. Then equation number 2 become undefined. So this is the logic we have written here. Now putting the value of Li in equation number 2. Sorry, just put this is equation number 3. Just put equation number 3. Right. Now putting the value of Li in equation number 2. So write down here, putting the values of Lix in equation number 2. We can get what we can get. F of x is equal to summation I 1 to n plus 1. yi is here already. Multiply. This is our I is move 1 to n plus 1. But I can never be equal to z. If it equal to z, it cannot be defined. So it is xi minus xj. This is our equation number 4. This equation number 4 is called the algorithm for this is the algorithm for our Lagrange's interpolation. This is the algorithm for Lagrange's interpolations formula. Means ultimately now we have developed that what is the algorithm, what is the logic behind for the Lagrange's interpolations formula. Our now next job is how to develop a Matlab code. We have to develop Matlab code for the Lagrange's interpolations formula. Same thing, we always use the function. For example, if I want to do, I always use the function here. I always use the function for the Matlab, right? Function will be whatever. Suppose I want to put x, I want to put y, then I can put like this. Now I have to input X, I have to input Y, and I have to input YP. I hope that those students, those who are interested in these interpolations, they must have seen my previous lab sessions. The lab sessions we have constructed forward difference table, then the divided difference table, and we did regarding the Newton divided difference interpolations formula. In that case, I hope you got that how we can input the value of X, how input the value of Y, how input the value of this. See, the value of X, value of Y, and this has to be input in the form of vector form. Now, let us go in the Matlab here. I hope now you can see the screen. I have shared a screen of the Matlab. Write down the functions, right? So all of us very clear that the function yp is equal to Lagrange. So I can write any of them here, Lagrange or this side. What is X? I want to input. What is Y? I want to input. And what is P? The P is the point of interpolation here. At what point you want to find out the interpolating value are here. Now look here, second line, CLC, it means it will clean your screen. It will clean your screen. So CLC. Next is that now I want to input X in the form of vector. I want to input Y in the form of vector. And I want to input the point P, which is called the point of interpolations. Now look here. Just X input. Enter the values of X in vector form. I hope those who have seen my lab session or those who have attended my previous lecture classes, they're very clear how to input X in the vector form, how to input in the vector form Y. Same thing I do here, Y input, enter the value of Y in the vector form. Done. Now come up here next. Next here, what is the P? Input. The input is the syntax here, right? Enter the interpolating point. Okay. Now next here, after that, what my plan is that after that, come up here. After that, let us come here. N is equal to length x minus 1. This is called a degree of polynomial is n minus 1. It is very clear there. Look here. In case of interpolation, if I have n plus 1 point, if I have this point, I can get how much? N degree of polynomial. Degree of polynomial. Same thing, the logic is applied here. N is equal to length s. Means if I have 10 points, I can get degree of polynomial will be 9. If I have 100 points, the degree of polynomial will be how much? It will be 99. So this is the logic behind here. Degree of polynomial is n minus 1. So this is the logic behind here. Now sum is equal to 0. Why it is used? Just look at the logic here. Why sum is equal to 0? Ultimately here in the algorithm we have two parts. One part is summation part. Whole is summation, right? Whole is summation. Second is our product. Okay. Now I need to find out the summation also in the product of yi and li. So for summation, if I represent Sm is equal to 0, first Sm is equal to 0, and next I can write Smn plus 1 is equal to 0 plus Sm. So accordingly, we are trying to increase the logic in this manner. But in the case of multiplication form, if it is a product, I cannot write that. If it is a product, start from 0. If it is product, it should be started from 1. Then only we can multiply. Otherwise, become 0. So Sm is equal to 0. Initially, suppose summation is 0 here, because we have summation along with the products. Now come up here, sum is equal to 0. After that, I apply the for loop. Look here. I apply the for loop here. What is the I? Number of terms. I will move from here 1 to n plus 1. So from here, loop for summation. Loop for summation means that I want to find out the loop in the form of summation. I will move from 1 to n plus 1. Next, I can use for the loop, which is the product, which is from I1 to n plus 1 here also. Come up here, I will move from 1 to n plus 1, because in the Lagrange's interpolation equations, look here, these equations are 1 to n plus 1. So it is moved like this. So logic is that I am first trying to target here first. Then I'll target the product. That's why in the second I have written here product. PR means product. Initially 1. Yes, I told you that initially product cannot be 0. If it is product is 0, then it is become 0, 0 here. Production terms. Now for J loop. J is for the product. Just look here. J here, in case of product, is J also here 1 to n plus 1. We have two loops. One is I loop and one is J loop. In this product, the I and J loop should move simultaneously, because in the numerator we have I, denominator we have I and J. Logic is that I cannot be equal to J. If I is equal to J, it is going to be 0. It means that for the production, for the product, we have to run two loops. One is I and one is J. But in the summation, we have only one single loop. Okay. Come up here now. J also move from 1 to n plus 1. Okay. Now come up here next. If I is not equal to J, or J is not equal to I, right? This signifies not equal to in the Matlab code. If I or J is not equal to, if J is not equal to I, then only our logic can be applied here. If I is not equal to J, then only this is a finite number. If I is equal to J, it becomes infinity. That's why the condition has been posted here. If I is not equal to J or J is not equal to I, then just write down the formula. What is the formula? The formula is product is equal to product 1, right? Is equal to P. Instead of X, I have written here P. Here, this P, this X is the points where we need to find out the interpolations. Now this P is equal to X now. X is equal to P now. Because I have to input what's the value of XC. Here X is variable, but here P is constant. Constant, just put the value of P. So instead of X, I have written here in the coding, this is P, right? P minus XJ divided by XI minus XJ. We are not doing anything new here. Just think about here product. Product, what I'm doing here, product, I have defined product is equal to 1. Initially 1, then product is equal to product, right? Multiplication, because I have to jump in the next. I have to jump in the next, because our J will move 1, 2, 3, 4 like this. So same thing we will do in the factorial n also. Same logic here, right? I can get n minus 1, right? N minus 2 like this. Same thing here. First product is 1 here. Product. Then apply the logic. Instead of X, I have written P, right? Minus XJ, right? XJ divided by, right? Divided by Just look in the previous era. We are doing nothing new here. P minus xj. Now it is point xi minus xj. We are doing nothing here, right? P minus xj divided by xi minus xj. We just retained the same formula here, and we moved the for loop I1 to n plus 1 under what condition? If I is not equal to j. This for loop, whatever we have designed here, this for loop, this minus xj. Whatever we have applied here for loop, j is equal to 1 to n plus 1. This for loop will run if j is not equal to I, then only this for loop will run. Otherwise, the for loop cannot be run because it becomes 0. If I is equal to j, this becomes 0. It means it's become infinity. This for loop is going to be run if I is not equal to j. If I is not equal to j, this will run. So this if condition has been ended here. Be careful. If it is not equal, then only this can be run. Otherwise, it is become infinity. And this end is end here. The j loop is now here ended. This if condition is ended here. If I is not equal to j, then only this is going to be applicable and this loop will be run. Then here I have stop here. Meaning is that in the explanation here, what I am taking that I have got this one and I have stopped. Now I need this one. Now I need this one. What was that? What was that? To get all these things now, come up here. Sum is equal to sum plus yi into PR. What is PR now? In our case, what is PR? Very clear here. P product is equal to now P product, right? P minus xj divided by xi minus xj, right? This is our PR. What was the formula? What was the Lagrange's formula? The Lagrange's formula was f of x is equal to summation of I1 to n plus 1 yi. Yi is with me. I have already multiplication of now this PR. Right? Because if represent now Li, right? This complete is represent now Li. So our formula was yi into Li summation. Now this yi I have already. Okay. Now if I do product with this one, I can get yi into Li. Okay. Now for loop will move now. I is equal to 1 to n plus 1 will move. How will it move now? What is sum now? Sum is equal to, right? Sum plus yi into PR. Then I can get sum up. Look here. Sum is equal to sum plus yi into PR. Then this for loop will be stopped here. Okay, got the point. Now I have developed this PR. The PR means actually Li. What was the formula? Yi into Li is equal to f of x was the Lagrange's interpolation. Okay, this is the Lagrange's interpolation. It is coming from this formula. Now I need to do sum only. So sum will be I to n plus 1. So this is sum. Okay. Yi into PR. This PR is what? Li. Now it is going to be end. Now, what is the answer? This is the answer. Because we require the total summation. Look here. Total summation is the answer. So if I need the y interpolation is equal to Sm. Now I have to end the function. Look here. Have you seen here? Sum is equal to sum plus yi into pr. This yi is given. This pr is li, right? This pr is li. Lagrange's interpolation formula was f of x is equal to yi into li. Got it? So sum is equal to sum plus summation yi into pr. Okay, now this for loop for I is complete, so I stop here. Now what is yp? Yp is the interpolating values is equal to sum of this n is for the given functions. We have apply here function here. Okay, now again I'm going to explain to here function yp means I require the interpolating value of y of given x. So Lagrange, you can write here as per your choice. Lagrange, x is input, y is input, and p also input. So I have put x, y, p as the input. What is the n? N is the length. It means it will give the degree of polynomial. If I have 9 points, I can get 8 degree of polynomial. If I have 100 points, I can get 99 degree of polynomial. So now sum is equal to 0. You may feel some things because Lagrange's interpolation is the summation of yi in li. So we'll start initially from summation is 0. So this for loop is for the summation, loop for summation. Second, PR is equal to 1. Why we require the PR? To calculate the li, coefficient of yr, they are the in the product form. So we start product from 1. We cannot start product from 0. If it is product from 0, multiplication become always 0, 0. So it is not possible. So we put it from 1. And this j is equal to 1 to n plus 1. This is the loop moving inside the product, right? In li. Now, this loop will be run if I is not is equal to j or j is not is equal to I. Why? If I and j are equal, then the product will become undefined. In that case only it is going to be run. The formula is PR. What is the PR? Product. What is the PR? Li. Right? We define what is the Li. PR is here actually Li. I can write Li also here. Okay? Is equal to PR into which is x minus xj divided by xi minus xj. Right? What is P here? It is the point of interpolation. Instead of x, I have written here P. Okay? So this j loop will now end here, and the j loop is the product loop. If j is not is equal to I, then only it is going to run. Otherwise, it is become undefined. Next, I have to end this j. Now, what is the sum? Sum is the final one because your formula is summation of yi into pr. So I have to sum up it. To sum up it, sum is equal to sum plus yi into pr. What is the pr? Pr is the li. Okay, sum here. So I have end here loop. Yp is equal to Sm. Ultimately, the value of f of x is equal to summation of yi into li. That's why I'm writing summation is equal to yp. Then I have ended here. Let us try to run this program. Now, if I run this program, run it. They're asking enter the values of x in the vector form. Let us try to enter in the vector form. How to? I hope all of us know how to enter it. 0, 20, 40, 60, 80, 100. So let us try to here. Yes. Now enter the value of y in the vector form. Again, input here. Suppose 26.0, 48.6, 61.6, 71.2, 74.8, 74.74, right? Next, 75.2. Now, if I run here, look here. So now I have input the value of x. Now I have to input the value of y. Enter the interpolating point. How can I cross-check that my coding is running perfectly? Just put the value of x, suppose 20. If I put 20, I should get 48.6. Means I can cross-check myself. If I put the value of x here, enter the interpolating point, it means it is asking the value of p. Means at what point you want to find out the interpolation of the given data set. How can I cross-check? The better option is that just put the value of x which is given to you, then I can get the corresponding values here. For example, if I put here 40, I should get, see, for 0 it is 26.0, for 20 it is 48.6, for 40 it is 61.6. Means I should get 61.6. Just enter here. Look, answer this 61.6. It means that our coding is working perfectly. It signifies that our coding is working perfectly. So this code is working perfectly, that we have cross-checked. We have input the value of x, we have input the value of y, then we input the interpolating value of x. Now we have cross-checked that if the value of x is 40, I can get exactly 61.6 values are here. Now I have understood that it is not too much difficult to develop the algorithm, everything here. Just look here, just repeat this one. We have classified two parts. One is coefficient of y, one is the value of y. The y is given to you. And we have to develop the algorithm for Li separately. So we develop, this is the algorithm for the Li. Then we put the value of Li in the equation, so I can get equation number 4. After getting the equation number 4, then we got here finally algorithm. Now we try to write the same thing in the Matlab, and we found that the code is working perfectly. The code is working perfectly. So it means that how it is simple to calculate the interpolating values if I use the Matlab code. I hope you have understood that how we can make the code in the Matlab very easily to calculate the interpolations of the any type of data set. Right? In case of Lagrange, there is no any restriction. It may be equal space, unequal space. There are lots of points. It doesn't matter. Once you develop the algorithm, apply it, develop a code, and we can get the value automatically. Thank you very much. Today I have stopped here. Next class we'll discuss another programming language, means Matlab coding development of different type of maybe interpolations, maybe numerical integrations, maybe how to solve the differential equations, maybe how to develop modeling in simulations, maybe in reservoir simulation and modeling for petroleum engineers. It can be developed in the Matlab code. Thank you very much. Today I have stopped my sessions here. I hope you have understood the lectures, you have enjoyed it. Thank you very much. You can leave now.